We're going to go over the Connect app for field maps. And the first step is to go into your profile in field maps and to the collection settings area and choose the offset function and make sure you have LaserTech Connect selected. If you don't see it there in the pick list, that means the app isn't installed on that device yet. Install that on the device, it'll show up here, and select it. And then also the provider. The Connect app and the GPS signals will come through location services. Under provider in field maps, you want to select integrated and you'll get your accurate GPS data coming through. So now we're ready to open up a map. Your map needs to have all the offset attributes loaded into it and ready to go. Got our location, GPS accuracy is good. The exercise then is to offset the location of a feature that's inaccessible out in the road. We're going to grab our GPS locations here and then measure with the laser to the feature out in the road where it's inaccessible or dangerous. Okay, the first method we're going to use for Connect is a distance angle method. And the setup here uses the TruAngle, the new TruAngle 2. That's the angle component of the method. That's our most precise method, allow you to work in urban areas, tight areas where the compass is going to be affected. We've also got the TruPulse 200i up here as well. Going to measure distance and angle for you. And then we're showing a Trimble DA2 receiver here with this setup as well. And then we're running the field map software and the Connect app as well. So to start the point for distance angle, I'm going to go ahead and start a point here and then offset its location. That's going to start up the Connect app because we chose that in the profile section. So the first time around, I'm going to need to connect to the laser and the TruAngle. I'll also connect to GPS at this time. And I'm going to use location services. As I mentioned before, you feed the GPS signal to location services on the Android device, and then the apps will use that information, both field maps and Connect here. So I've got that started and I'm ready to go. I'll choose distance angle method. You'll see values for antenna height, instrument height, and target height. You want to get those measured in. It'll give you a good accurate ground elevation for all your points. So the antenna height would then measure up to the bottom of the antenna, and then the laser right to the reference point on the laser, and record those values in the app and you're ready to go. What we're doing here at this post is we're going to log this as our backside point, and then we're going to move over to where the feature is and take our shot out to it. So the backside point, we're maybe 50 meters away from it here. We're simulating using RTK. You can be nice and close with your backside point here. If you're using a GPS that's 1 to 2 foot or worse accuracy, you want your backside to be farther away, 100 meters or more. Get a longer baseline on there. It's going to give you a better reference azimuth to use. So we'll go ahead and log this point here. I'm going to use the base. It's tilted. I'll be able to see that base there. All right, that's done, and we're ready to move up to the station where we're going to measure to the feature. So we've moved over to our station now where we're going to set up. We've got a good view of the feature out in the roadway and a good view of the backside point. So now we can log our location here and save that point. And then it generates the reference azimuth back to the backside point. Now what we'll do is go ahead and just aim at that backside point with the encoder and zero it there. So now we just spin over and shoot at the feature. And you can see the distance, angle, inclinations all recorded there and the offset coordinates. So then we tap save and the point comes right back into field maps. We're going to go over the distance method now for Connect. And that you can use with any laser. It can be a 200 model, a 360, 200X, 200i, doesn't matter. It's going to use just the distance and the inclination to the feature for the two shots. So I've got my feature out in the roadway here. I can get to within about 50 feet of it here. So I'm going to set myself here, and I got another spot over to my left about the same distance away. That's kind of the geometry you want to try to achieve. You don't want to have your two GPS points real close and your feature far away, or vice versa, real close to the feature and your GPS points real far away. Try to build like an equal-sided triangle between the points. So I'm going to start field maps here, and I'm going to offset my location. It brings up the Connect app, connect to the laser. I'll connect to GPS. Okay, everything's good. I've got GPS going to location services. So I'm ready to start the distance method. First step is to collect my point where I am here. I collect that, and then it prompts me to shoot to the feature out in the roadway here. So I'll go ahead and take that shot. And I see that's come through. It's ready for the next point. Okay, I have moved over to my second control point for the distance method. So I level up my pole, I grab the GPS location, and then I aim back to the feature out in the roadway, and take that second shot. And your second shot comes through. So we tap next, we see a map display of our 2 points. So you've got your 2 control points on there and then 2 solutions for that feature. One on the left side, say, and one on the right side. So you just look at the map, it's got a good north orientation here, and I just make sure, looking from CP2 back to CP1, that feature is going to be on the left-hand side. So I can just use the toggle button here to choose the proper side and tap save, and the point's back in field maps. So we're going to go over the distance azimuth method with the Connect app. It's the simplest method, allows you to just connect a single point and take a single shot with the laser. We've got the 360i model here for equipment today. It has the electronic compass in there to provide the azimuth value. So I'll start field maps. I'll go ahead and start a point, offset from location. Connect app starts, connect to the laser. I'll connect to GPS. Okay, we're connected. I'll choose distance azimuth method, and I'll grab my location where we are here. And then I'm ready to take the shot to the feature. New coordinates generated. I tap save, and the point's back in field maps. That's the distance azimuth method in the Connect app. Another thing you can do before you get started with your offset location is record a height or a missing line value for that point. Say it's a tree, you want to record the height, or it's a fence and you want to record how far away it is from a building. You can make those measurements before you take your offset shot, and they'll get added right into the string and back into field maps.